Chapter 5, Section 1, Multiplying Polynomials. In this master video, we're going to look at specifically multiplying binomials. Okay? So a binomial is a polynomial specifically where there are only two terms. So I have x minus 1, x minus 3 in brackets, and because they're right next to each other, well, they're being multiplied. Hence, I'm multiplying two binomials. Well, how do you do that? Well, there's a bunch of different methods, and I'm actually going to show you three. One involves the use of algebra tiles, which is what was introduced in the previous video. So let's try that. So here's how it works. Now I'm multiplying x minus 1 by x minus 3. So what I've done is I've drawn out x minus 1 using algebra tiles. So here's my x, and then the minus 1 is right here. Remember, they have to be the same width. So I've laid it out this way. And then I have x minus 3. So I have a positive 1x, so there's my bar right there. And then I have minus 3. So that's why I have three of these little dark unit squares. So you think of these algebra tiles like I'm multiplying a bunch of rectangles together. So this is the length, or the width, I guess, and this would be the height. So what happens when you multiply a length and a width together? Well, with rectangles, that gives you an area. So I'm just going to fill in these spots here as best I can. And there we go. So you can guess now, you don't have to think about it mathematically, just fill in the shapes using common sense. This has a width of 1, but it's negative, and this has the length x. So the only thing I can fit in here is a bar. So that goes like so. I'm lining it up as best I can. Next, I have this little width here and that length there. So it's not difficult to see. I can put 3. Oops, I don't like that one. Trying to draw it as best I can. 3 of these bars, like that. All right, and then this bottom corner, well, I can only fill them in with little squares. Now, they're not perfect squares because, well, I'm not a perfect drawer. There we go. Come on. There we go. All right, so everything is filled in. So I just got to determine the area of all these tiles that I've drawn. Let's get the signs right. Okay. Should this be shaded or unshaded? Well, how did I make this? How did I create this? I did it by multiplying positive x by positive x. Therefore, that is positive x squared, so this remains white. This bar here, however, okay, that was created by multiplying positive x by negative 1. Okay. Well, negative 1 times x is negative x. So this bar, I need to color that one in. Okay. So just checking the sign of each tile that I drew one by one. So I drew this tile. Well, that was generated by multiplying positive x up here times a negative 1. And in fact, all three of these bars were done the same way. A positive x times a negative 1. So all three of these bars here need to be colored in. All of them. There you go. Okay. All right, and then these little unit squares here, this was a minus 1 times a minus 1. Well, a negative times a negative is positive. So in fact, all three of these have to remain white. So we are actually done. And let's write out the product algebraically. I have positive x squared, and I have 4 of these bars, but they're all dark. So this is minus 4x plus 3. So when you multiply x minus 1 times x minus 3, you get x squared minus 4x plus 3 if you use algebra tiles. Doing another one, 2x plus 1 multiplying x minus 2. So I'm just going to write 2x plus 1 horizontally this way. So I have two positive x's and a positive 1. And then going down, I have a positive x and then minus 2, two little squares that are shaded. Okay? So think of this as the length and the width, or the height, of a rectangle. So multiplying them together is just going to give me the area inside. So I'm just going to fill in all the pieces. Right. So that bar, multiplying that bar, I'm going to get a large square. Something like that. Good enough. And then I'm going to have another one here. Okay. Over here, I'm going to have a bar. Oof, it's ugly. There you go. Like that. And then down here, I'm going to have 4 bars. So I usually just get all the shapes in first, and then I look at each one and decide what their sign has to be. But if you want, you can determine their sign as you go. Really all you have to do is just figure out which ones are negative, then shade those, and you're good to go. In this corner goes 2 little squares, like that. Okay, so let's see if anything gets shaded. Right? Well, a positive times a positive stays positive. Same thing with this. Positive times positive gives me positive. So all this stuff is positive. But the negative tiles down here, okay, I had to use those when I created everything in this row here. Okay? So a positive bar times a negative is negative. Okay? And negative times positive is negative. There we go. Same thing here. There you go. And here as well. Okay. These little squares, this was a positive 1 times a negative 1. So that's negative as well. Okay. And again, we don't have to shade this bar because this bar was created from multiplying positive 1 times positive x, which is positive. All right? So we're done. So I'm just going to write out algebraically what this product is. This is 2x squared plus x minus 4x minus 2. But of course I can combine these two like terms in the middle. There. Come on. There we go. This is going to give me 2x squared minus 3x. Oops, that one disappeared. Come back here. Minus 2. Minus 2. Okay. So that is the simplified answer algebraically. Algebra tiles. Not a fan of the algebra tiles? Well, there are other methods that will allow us to multiply two binomials together without them. So method 2 here is the distributive law, or the rainbow rule, which we all know and love, but there's just a little bit of extra stuff added. Okay, so just temporarily, see this negative 1 here? Let's pretend that it's not there. I'll put it back in just a second. Now, you would normally have no trouble multiplying this x by that x, and then this x by that negative 3 using the old-fashioned distributive law. No problem. Well, then what you do is you would uncover this negative 1, and then cover up the x. And then we do the same thing again. We multiply the negative 1 by each item. So it's like a double rainbow rule. So the x multiplies the x minus 3. He gets his turn. And then we have the minus 1. And that gets to multiply the x minus 3. Okay? So I just have the double rainbow, so to speak. So now I can apply the rainbow rule as I normally would. So x times x, I get x squared. X times negative 3, negative 3x. Negative 1 times x, negative x. And negative 1 times negative 3 is positive 3. Okay. Well, at least all the brackets are gone, and we're just going to collect any like terms. And we have two terms in the middle. So this gives me negative 4x plus 3. And there we are. Had we used algebra tiles and colored everything in and written out our answer, we would have gotten the exact same thing. Let's do another one. 2x plus 1 times x minus 2. So I'm going to use distributive law twice. So I'm going to use the 2x first. So he gets to multiply x minus 2. And then plus 1 times x minus 2. All right. So I get 2x squared minus 4x plus x minus 2. Combine any like terms. We have a couple. Negative 4x plus x, negative 3x, and minus 2. Okay. So that is method 2 using the what I guess I'd call the expanded distributive law. Method 3, I call this the quick trick. This is the method that I was taught when I was in school. It's nice because it's quick and it's easy to remember. You have 4 letters to remember. Here, I'll do this in red. So F. F stands for first. O. O stands for outside. I stands for inside. And L stands for last. So first, outside, inside, last. So it spells us FOIL. Okay. So if you can remember the word FOIL, okay, that will tell you what to do. So the first means we multiply the first 2 terms of each binomial together. So I'm just going to draw a little bump like that. So I multiply x times x, which gives me x squared. The O stands for outside. So I'm going to multiply the terms on the outside. So that would be x and negative 3. So x times negative 3 is negative 3x. The I for inside. So I take the inside 2 terms. So this is negative 1 times x. So that gives me negative x. And then L stands for last. So the last 2 terms, negative 1 times negative 3, which is positive 3. Okay, and we actually have the exact same thing. Combine like terms. And there we go. We get the exact same answer. It just allowed us to skip this step here from method 2. So if you can remember FOIL, that just tells you which terms to multiply together, and then you combine them, and then you're done. Let's do another one. So FOIL first. O for outside. I for inside. So 1 times x is just x. We usually don't write 1x. And L for last. All right. Multiplication's done. So let's just simplify, combine like terms. Negative 4 plus 1, so this is minus 3x. And we should get the same answer as before. Looking up, yes we do. So I find that most kids like FOIL because FOIL is an easy word to remember and it's fast. But there's one thing you have to remember. Okay? FOIL is it's a special technique, which means it only works in certain instances. And it's only useful when you are multiplying two binomials. That's it. Okay? If you're multiplying trinomials together or more than two binomials, FOIL doesn't work. Okay? You have other things that come into play. But if you have a simple binomial times another binomial, FOIL works just fine.